Okay, so now what we're looking at is the cell. So as far as the cell goes, there's two big components to what you need to know here. I don't have anything in my teeth. I just ate lunch. One, you need to know the cell membrane. And there's three things that you need to know about the cell membrane. There is going to be what makes up the structure of the cell membrane and what are the properties of that. What are the functions of the cell membrane? And what are the two different types of proteins? And can you name an example of that? The other part of the cell is learning about the organelles and what they do and what their functions are. So we're going to focus on the cell membrane here. So what is the cell membrane? You can see it covers the outside of the cell. It's going to separate the outside from the inside. The outside is called, and everything in the body happens in fluid. We're an aqueous beings, which means everything is fluid. So there's a fluid that's outside, there's a fluid that's inside. The fluid that is outside is called the extracellular fluid, the ECF. The fluid that's on the inside is called the intracellular fluid, extracellular fluid, and intracellular fluid. So ICF. The intracellular fluid is made up of this stuff called cytoplasm. And what cytoplasm is, it's all of the organelles and the goo that it's floating around in. That's what I like to think of. Cytosol is like a goo, and the organelles are just kind of floating around in it. There are some proteins that provide some structure. There's a cytoskeleton that makes it so it's not just kind of gelatinous, but the cytoplasm is both of these together. So cytoplasm and cytosol can be confusing. Now, the cell membrane contains all of that stuff. Okay, so let's look at the structure. So first question is, what is the structure of the cell membrane? What is it made out of? Well, it's made out of a lipid bilayer, phospholipid. So these phospholipids, and it's in a bilayer. Bi means two, so it's in a double layer. Now, the phospholipid bilayer is pretty cool because it is made of phospholipids. Now, what is interesting about a phospholipid is it has a hydrophilic head, which means hydro means water, philic means love. It loves water. That's because it's got these polar groups on it, and like dissolves like. Polar things love polar things, and water is a pretty polar molecule. And if you're confused on polar, all that means is that it's unequally sharing electrons. So it's going to create a difference in charges. So the electrons, which are negatively charged, are going to be hanging out near the oxygen more often. So that's going to make this mostly negative, or more negative than at least the hydrogens, which are going to be slightly positive. So water and these charges are going to be attracted to each other. So the slightly positive hydrogen is going to be slightly attracted to the negative. So they're going to like each other, hydrophilic. The hydrophobic part are these hydrophobic tails. And these are nonpolar molecules, which means they're good at sharing. There are no partial charges. There's no unequal sharing of electrons. They're all the same. So this is going to be stuff like oils. This is going to be fats. And so what happens when you take oil and water and you try to mix them together? They don't mix because nonpolar doesn't have any charges. So water's like, we don't have any charges. There's nothing for me to like on here. So it is hydrophobic. So what happens is when you put these things in water, if we were to have a beaker of water and you were to put these, you had like a jar of them and you dump them in there, what would happen is the hydrophilic heads are going to go towards the outside in the water. They're going to go towards the water. And the hydrophobic tails are going to try to hide away on the inside, away from the water. The hydrophobic tails. And that's what's going to put together your phospholipid bilayer that's going to allow things to stay inside, and it's going to keep things out. The intracellular fluid is made of fluid. The extracellular is made of fluid. Now, as far as the plasma membrane goes, it is still a lipid. So it's going to be what's called selectively permeable. And what does that mean? It's going to keep things from getting in and only allow certain things into the cell. So if we look at this, what is going to be allowed through the cell or through the membrane? It's going to be small substances, very, very small things. or lipid soluble things, things that are made of fat. So, for example, your T3 and T4 hormones, which are your thyroid hormones, are going to be able to pass directly through because they are small and they're fat soluble. So they're going to be able to pass right through your membrane. Um, Other things that can pass directly through are going to be small molecules like oxygen. Oxygen's going to pass directly through the membrane. It's going to diffuse directly through. CO2 is not. Or I mean, CO2 is. It's going to be able to diffuse out. And this makes sense because oxygen, as we learned with metabolism, is required for burning glucose to make ATP. So we would want this to get in really easily and really rapidly. Now, what cannot pass through it? It's going to be things that are polar or things that are more hydrophilic. They're not going to be able to go through. So, for example, glucose is a polar molecule. It is, and it's big, and it's got some charges, partial charges on it. It's not going to be able, it's going to bounce right off. So how does glucose get into the cell? How does sodium get into the cell? There's a ton of positively charged sodium just chilling on the outside in our extracellular fluid. How does it get in? It's got to pass through these proteins. So not only does the cell membrane made up of phospholipids, it's also made up of different proteins. So what did we go over? We went over what is the structure? Phospholipids, amphipathic, hydrophilic tails, or I mean, sorry, hydrophilic heads, hydrophobic tails. There's also, and then what passes through? Small fatty substances can pass directly through, gases can pass directly through. What cannot pass through? Anything with a charge on it or that's bigger. How do those things get in? Because glucose is pretty important to a cell, right? It's how we make energy. It's got to pass through a protein. So now that gets us to our second part of our plasma membrane is there are different types of proteins that are involved in it. There are many, many different types of proteins. So what types of proteins are we looking at? There's two very just global classifications of things that you'll want to know. There are integral proteins or transmembrane proteins, and then there are peripheral proteins. The integral or transmembrane, trans means across, transatlantic, transcontinental. They're going to travel the entire span, also known as integral. They're completely integrated in there. They're going to go through the entire span of the membrane, pass from one side to the other, like a tunnel. Peripheral means on the outside. So you have peripheral nervous system, that's the outside. So if you see, you have peripheral proteins that are either on one side or the other. They do not pass directly through. So you'll have like some anchor proteins, you'll have some other signaling proteins that are going to be on the outside and the inside of the cell. So that's the main difference. So what is the difference? What are the two types of proteins? Question one, integral transmembrane and peripheral. What is the difference between the two? Transmembrane goes all the way across, like a channel protein. Peripheral proteins, they're on one side or the other, the extracellular side or the intracellular side. Perfect. Okay, it's almost three, sweetie. The last question about your cell membrane is what are the functions of the plasma membrane? You should be able to tell me these. You should be able to tell a friend. You should be able to tell your cat or your dog. You should make an index card. Put it on there. What are the functions of the cell membrane? Flip it over. Be able to say those out loud. So define the boundaries of the cell. That makes sense. Separates the intracellular, extracellular. We did that. Provides structural support for the cell so that it doesn't just like fall apart into goo. It provides protection. It regulates what goes in and what's out. We already saw that. And it can detect changes on the outside of the cell. Perfect. So that's what you need to know for the cell membrane. Those three things. Oh, let's see if I can find let's see. Can't seem to find. I don't know where that went.